My name is Faiz Hassan from Advanced Nanomaterials Research Groups, or known as ANOMA, and the Faculty of Science and Marine Environment, Universiti Malaysia, Terengganu. So today I would like to talk about the relationship between morphology, structural, and conductivity based on starch-sodium bicarbonate thin films. Uh, Yeah, in the study, starch and sodium bicarbonate were chosen as the starting materials for solid-state film preparations. In general, this film is actually to uh, be used as a tool functioning components in electrochemical devices, as an ionic conductor, and also as a separator. So let's get some information about starch and ionic dopant first. Okay, starch is the richest bio molecule and the most carbohydrate reserve in the plant roots. It's a multi-purpose and economical material and has many roles as gene agent, water binder, thickener, and emulsion stabilizer. In electrochemical research work, this water-soluble polymer have been utilized as a solid electronic host due to its flexibility structure and its ionic conductivity in a closed system can be enhanced by adding of selected ionic salts. For ionic salt or ionic booster, we using sodium bicarbonate. Okay, generally, is a chemical compound with the formula NaHCO3 and is commonly useful as a pH buffering agent and electrolyte replenisher, systemic equalizer, and been used in tropical cleansing solutions. Interestingly, from previous work, it had shown that uh, the process of polymers are based on sodium bicarbonate as a membrane possess uh, very good or high ionic conductivity from 10 power of -4 to 10 power of -3 Siemens per centimeter, making this hybrid membrane interesting for advanced explorations. So to understand the influence of sodium bicarbonate on starch-based electrolytes, the present work is reporting the investigation on morphology, structural, and electrical conductivity uh, on this hybrid starch sodium bicarbonate polymer electrolyte. Yes, there are no doubts that solid polymer electrolyte have some advantages as found in literature review as listed here. First one, no possibility of leak. It can straighten of cells thanks to the all solid state construction and improve the shape flexibility properties and lowering the cell weight. Okay, all solid state actually do not need heavy metal casing. Okay, some dendrites growth during charging, discharging can be prevented, and it can offer better overheat and wider operating temperature from -40 degrees Celsius to 150 degrees Celsius compared to liquid electrolyte from -15 degrees Celsius to 60 degrees Celsius. And the last one, it can improve the safety of the cell itself during electrochemical reactions. So over here we have developed two objectives. The first one to get the solid state film first, and then their structural morphology and electrical property will be investigated based on the selected technique. All right. Yeah, in this preparation sections, the membranes are preparing using a solution casting technique. We have starch and sodium bicarbonate as our first uh, our starting material, which is diluted in water and glycerines. We stir this mixture to get the homogeneous solution. After get it, we pour in a petri dish and left for naturally dry. And for the dry in desiccator, at the end of the process, we'll get the membrane film based on starch and sodium bicarbonate. And their structure modification, the evolution of the morphology and electrical property will be investigated through the optical camera, SRD, FDR, SEM, and also electrochemical spectroscopy, or known as EIS. It is some result based on this current study from optical image. We can see that the film switches from transparent to opaque in relation to the different amount of salts. Okay, hypothetically altered the morphology and structural respectively. This modification is expected due to the proton and hydroxyl ion, which play important part for adjustment functionality of polymer structure, as the electronic state can be organized by altering oxygen of stoichiometry and or protonizations. Okay, this is the SRD result. We analyze at room temperature, record from 2 theta equal to 10 to 80 degree. Okay, for complex films. Okay, we can see that based on this SRD pattern, two humps or variable peaks can be observed in between 10 to 26 degree and 26 to 41 degree respectively. Basically, this peak can be identified as uh, uh, the amorphous state of starch. Okay, fundamentally, the structure quite good in good agreement with those who study in the similar material. Okay, with addition 5 to 38% of sodium bicarbonate, we found that no new peak can be observed, and the pattern also do not significantly change. Nevertheless, the intensity of the visible peak altered with response to the amount of salt. Okay, as a conclusion based on SRD result, we can say that the complex film were not completely amorphous, but it was partially crystalline. Okay, this is the FDR result for the prepared films. To be summarized, okay, it can confirm that the chain reaction polymerization process is successfully realized due to the existence of modification of each change in the spectra. By relating the spectrum of starch with those complex films, and make assumption that the complex film spectra presented all of the distinctive band of starch and sodium bicarbonate, and did not demonstrate any new bands, which confirm that no other chemical reaction occur in the film. Okay, this is the scanning electromicrograph for the complex films. Basically, all the sample in solid form and analyzed at different magnification from 300 to 10,000 times. So as can be seen in the pure and 5% uh, of sodium, morphology appear to have regular and flat shape with smoothest uh, surface texture. Okay, addition 10%, we have a new texture appear with a small ringlets, right, on the surface in a small quantity. And when we add a 15 to 28% of starch, we found that the surface counterfilament significantly modified with a small and a large wrinkles, as shown by yellow arrow over here. Okay, when we add another 25 to 38%, we found that the surface further modified with appearing many black spots are represented by a red circle in the image spread on the whole area of films. This black spot actually can be referred to the pore structure, which form the response to the addition of salt. Okay, and we can see that the black spot, the pore size of 20%, 25% is smaller compared to the uh, sample with a 30 percent of salt. Okay, figure 8 shows the variation of conductivity, all right, with different amount of ionic salt in complex films. Okay, we can see that for pure film, the calculated conductivity is 1.41 times 10 power of negative 6 cm per centimeter, and increasing to 2.31 times 10 power of negative 6 for 5% of salt, and continue increasing up to 25% of salt. So with addition of 38% of salt, the conductivity drop afterwards. So we can conclude based on this result that 25% of our salt is the conductivity optimizing concentration. Uh, yeah, it's anticipated that ion association take place at low and high salt concentrations. At an intermediate salt concentration, the association and re uh, the association of salt occurs. The drop in conductivity could also be due to the increase in crystallinity, as proven by increase in intensity of the X-ray diffractogram result. Okay, as summaries, novel solid polymer electrolyte based on starch, sodium bicarbonate has been well prepared by a simple solution testing technique. The complex film slightly amorphous rather than crystalline, and the highest conducting membrane was 25% of sodium bicarbonate, given the conductivity value to 4.41 times 10 power of negative 5 cm per centimeter, and its high electrical conductivity was believed attributed to main factors. The first one, the high amorphicity of the material, and the second one, the contribution from the high volume of mobile ion during electrochemical reactivity. Okay, before I finish, I would like to thanks to UMT and KPT for the financial support, and to FSM and FTKKI for the facility support. Thanks also to my research collaborators, as listed here, Dr. My PG and FYP students. That's all. Thank you very much for your attention.